All right. So today's lesson is on negative and zero exponents. And this is probably my most favorite lesson because I just think that negative and zero exponents are both really cool. So the first thing that you need to do is remember you're going to write down your I can statement. You're going to get that from the handout that you were given for your Unit 6 journal. So it's going to start off something like I can. And you're going to fill the rest of that out. Okay, this is your 6.1c, negative and zero exponents. So a couple of times we've worked out in our journal or gone through homework answers, and I've told you that we typically don't leave negative exponents. We typically just don't leave negative exponents, and that's because it's just mathematically inappropriate. So when you have a negative exponent, the way to eliminate that is to write the base as its reciprocal. So if I had a base of 3 to the negative 2 power, well, I have to write the base as its reciprocal. The reciprocal of 3 is 1 over 3, and now the exponent becomes positive. Now the exponent becomes positive. Zero exponents, on the other hand, any non-zero number to the power of 0 is just 1. And that's kind of counterintuitive. It doesn't make a whole lot of sense until you maybe see an expansion of some powers. So I'm going to take an exponent and a number that we're real familiar with. So 2 to the first power is just 2. 2 to the second power is 4. 2 to the third power is 8, and so on. You see, each time we are multiplying by 2. Each time we get bigger by multiplying by 2. So just like when we're finding slope, if we want to find the before numbers, right, you have to do the opposite. So instead of multiplying by 2, I'm going to divide by 2. 2 divided by 2 is 1. What about 2 to the negative 1 power? Well, I take 1 and I divide it by 2, and that gives me 1/2, which is really funny because 2 to the negative 1, well, the reciprocal of 2 is 1/2 to the first power. Okay, that's where that whole negative and 0 come into play. What about 2 to the negative 2? Well, that's the same thing as saying 1/2 divided by 2, and half of a half is a fourth. And that's because 2 to the negative 2 power is the same thing as 1 over 2 to the positive 2 power, which is 1/4. So we're going to use these rules today. And I like to think of negative exponents as bunk beds. I think if you just have a whole number or an integer, meaning no denominator, raised to a negative power, I think of it as being on the top bunk. So I've kind of got you some bunk beds set up here. And this big black line is my fraction bar. So this is the numerator. So if I'm in the top bunk and I'm not happy, meaning I have a negative exponent, I move down to the bottom bunk, and then I am happy. But you still need something in the top bunk, and you're always going to put a 1 there, unless there's another term that does not have a negative exponent on it. Well, so now I'm in this middle bunk bed, and I have 1 over 5 squared, which is the same thing as 1 over 25. The rule that we just learned is if you have any number to the negative power, you write it as its reciprocal, and your power becomes positive. So let's look at our first example. Example number 1. Notice that 3 is happy in the top bunk, x to the negative 2 power. That's in the bottom bunk. It is not happy. So I have to move it from the bottom bunk to the top bunk. When I do that, I still have to put something in the bottom bunk. You can't just leave a hole, whether it's the top bunk or the bottom bunk, numerator, denominator. Well, we know that anything over 1 is just that number, so this just becomes 3x squared. When I look at example number 2, the whole quantity, the entire fraction, 1/4, is being raised to the negative 2 power. Well, if I use my power rule of quotients, that just says that I can distribute that power to every term, right? That's a good way to think about it. Well, 1 is to the negative 2 power in the top bunk. I'm going to move it down to the bottom bunk. Happy, 1 squared. 4 to the negative 2 power in the bottom bunk gets moved to the top bunk, 4 squared. Well, what is 4 squared? 4 squared is 16. What is 1 squared? It's 1. So your final answer is 16. Or you can use the rule that you just learned that says to get rid of the negative exponent, you reciprocate your base, 4 over 1, and now you have a positive exponent, the quantity squared. Well, that's just saying 4 squared times, like 4 squared, or 4 times 4, which is 16. So either way, you get the same answer. So let's use the rule for this next example. Example 3, I have a quotient, 2x over 3y, all to the power of negative 3. So again, if I want my exponent to be positive, I have to write the base as its reciprocal, 3y over 2x. And now that is to the positive 3 power. So I have to distribute this power to every term inside of the parentheses. So that becomes 3 to the third power, y cubed over 2 to the third power, x cubed. Well, 3 to the third power is 27. So I have 27 y cubed over 2 to the third power is 8 over 8 x cubed. All righty. Example number 4. Again, I have this entire quantity being raised to the negative 2 power. So I'm going to write it as its reciprocal, 3 over 4x squared. And now it's to the positive 2 power. This has a negative out in front of it. I always put my negatives in the numerator. So it doesn't matter whether it starts in the top or in the, like, if you have a negative off to the side equal with the fraction bar, I just move it to the numerator. A negative times a negative is a positive, so it doesn't really matter. So now we're going to distribute this power. So that gives me negative 3, the quantity squared, over 4 squared, x to the 2 times 2 is 4. Well, negative 3 times negative 3 is 9. 4 squared is 16, x to the 4th. Okay, let's look at example number 5. Example number 5 has this entire quantity raised to the power of 0. If we use the product rule that says you can distribute your power outside into the parenthesis, that becomes 3 to the 0 times x to the 0. And we know anything to the 0 power, any non-zero number to the 0 power is just 1. So this just equals 1. When I look at example 6, be careful. Example 6 is different than example 5 because I have 5 times x to the 0 power. X is being raised to the 0 power, which is 1. And 5 times 1 is 5. Okay. Our last two examples are pretty unique. They are equations. These are exponential equations. And the idea is when the base is the same, you can drop the base and set the exponent expressions equal to one another. And then you just solve. So the bases are the same. So I really have the exponent expression 2x minus 3 equal to x plus 2. So I'm just going to solve this equation. I'm going to subtract x from both sides. That gives me 1x minus 3 equals 6. Add 3 to both sides, and that gives me x equals 9. Well, I just don't know if I can believe that, so I'm going to try and do a check. So I'm going to steal some space off to the left side and do a check because I want you to see how this works. This means that if I let x equal 9, I have 4 to the power of, let's see, 2 times 9 minus 3 equals 4 to the power of, remember, x is 9, 9 plus 6. Well, 2 times 9 is 18, and 18 minus 3 is 15. And 4 to the, well, 9 plus 6 is also 15. Okay? Remember that when you get two equivalent, when you get two numbers that are equal to each other, you get a true statement. That means that you've completed your check, and that just means that your solution is correct. So in these last two examples, we're solving for x. Example number 8 is a little bit different because the bases are not the same. However, 16 can be written as a power of 2. 16 is the same thing as 2 to the 4th power, but it's being raised to the power of x plus 1. That means that I have to distribute that power. So my bases are still the same. My exponents, 3x plus 5, equals 4 times x plus 1, the quantity. So I'm going to have to do some distributing here. 3x plus 5 equals 4x plus 4. I'm going to subtract 4x from both sides. Negative 1x plus 5 equals 4. Subtract 5 from both sides. Negative 1x equals negative 1. That means that x equals positive 1. Again, I'm going to check it. I'm going to check my solution. So 2 to the power of 3 times 1 plus 5 is equal to 16 to the power of, remember, x is 1, 1 plus 1. Well, 2 to the power, what is 3 times 1? 3 plus 5 equals 16 squared. Well, 2 to the 8th equals 16 squared. So when you put that into your calculator, if you were to pick up your calculator, and 2 to the 8th power equals, whoops, you're going to use your caret function. 2 caret 8 equals 256. And 16 squared is also 256. Your check is complete. That means your solution is correct.